Hello. In Protostructure 2022, we redesigned the loading system that we use to define loads on elements and developed a flexible loading editor. In this video we will examine how to insert cladding loads using the new load editor. Claddings are objects that can be inserted on purlins and girts in the model. Therefore, in our project, we must first define the purlin and girt elements. Let's switch to orthogonal mode by pressing F12 and define cladding objects. The cladding command is located in the Steel Elements section of the Model tab. When we wait for a few seconds on the cladding command, the hint window opens and gives information about the use of this command. After running the command, we can select the purlin group or the girt group. The group objects to be selected are marked in red. Let's insert the cladding by selecting the purlins. In the cladding editor window that opens, we can change the cladding dimensions by changing the offset settings of the corner points of the claddings. Let's close the window completely. Similarly, let's add claddings to other girt and purlin elements. After inserting the claddings, we must determine the load cases and load combinations that we want to use within the scope of our project. For this process, let's open the Load Cases and Combinations section in the loading part. In the Load Editor window we can choose the load cases that we want to use in our project. So, Protostructure includes the combination with the relevant load cases in the combination list in accordance with the selected design and loading codes. For vertical load combinations, G and Q options are marked automatically. We can cancel the pattern load case within the scope of our project. Let's include the load case QR in the combinations to define the live load on the roof in our project. Similarly, let's check the snow load and rain load option. In horizontal load cases, we can set the seismic load case as equivalent static or modal respawn spectrum in this section. Let's continue by choosing the equivalent static load. Similarly, let's include the wind load case in this section. We can also include the negative load cases in the combinations. Thus, in addition to WX and Y loads, WXY options are also used. Since cracked sections will not be used in the design of steel elements, the option to create different load combinations for the design of steel elements must be ticked. Then, when we click OK, combinations are created for the load cases that we have chosen in accordance with the selected design and loading codes. If we want to use a new load case other than the load cases we have selected in this section, we can add a new load case for this process by selecting the Add option from the Load Cases section. For example, suppose that we have solar panels on the roof within the scope of our project, and I want to define a different load case for the solar panels in this process. Let's give a name GE for the load case. For the definition of load case, let's write GES as Solar Energy Systems. Let's mark this load case we added as a user-defined vertical load. At the same time, we mark the option to include in story mass calculation to be included in the earthquake calculation and close the window with OK. This adds the GE load case to the load combination editor. What we need to do after this stage is to create the combination we want to include this load case. For example, after selecting the first combination, let's press the Add button. Let's change the combination name here to G plus GE. Let's change the coefficient of the GE load case to 1 and the coefficient of the G load case to 1. Thus, we have included the load case that we have determined into the combinations. Let's close the window with OK. Now we can move on to the load assignment process on the claddings. When we want to assign loads on any cladding, we select the relevant cladding object group and then right-click on it and choose Edit Loads. In this pop-up window, only the object group that we have selected is included. Here we see the load cases that you have added while preparing the load combinations. When we select the G load case, the active load case is displayed in the upper left corner of the window. In the top menu, there is the command to define the area load on the claddings. This menu is also among the options where loads can be deleted and reported in bulk. In the View Options menu, there are settings where you can customize all the settings in this interface. On the right menu, there are visibility settings. Now, let's define the area load in case of G load from the load case list. After selecting the area load command, there is information about the load in the lower left corner of my window. Here the label of the load is designated as G1. Protostructure sets this tag to be the same as the load case. At the same time, we see the direction option. Again, the Protostructure sets the default direction option as gravity by specifying that the loads will be in the direction of gravity or their movements will be in the direction of gravity. However, let's not forget that we can change direction using global or local coordinate systems from this section. Just below we see the value related to the size of the load. We determine the load as ton per meter square, that is, area load. Let's determine the area load that we want to define to the cladding here as 0.030. Then the load preview will be displayed when we hover the cursor over the cladding objects. Load is added when we select any cladding. There is a label and size of the load on the load. Other cladding objects can be loaded similarly. We can load the panels by selecting them one by one, as well as by dragging method. For example, let's select the panels between 3 and 5 axes by dragging method. When we finish the dragging process, these panels will be loaded. As a different alternative, we can copy the loads we have added and paste them on the cladding objects that we will specify. For example, after selecting the cladding load in this section, let's right-click on it and select the Copy option and select the panels we want to copy the load by pressing the Control button or by dragging method. Then right-click and paste. On the loads created, by copying the load from which they are derived, and the cladding numbers are located. When you want to make a collective change about the determined loads, we select all the load cases and right-click and select the Edit option. Then we can change the label direction or magnitude values in the Load Properties section. For example, let's edit the cladding tag here as a cladding instead of G7. Let's update the magnitude value as 0.035. Then when we click the Update button, we can see the changes on the cladding objects. Now let's load the solar panels in case of GE load. First, we select the GE load case from the Load Cases section. Then, by selecting the Area Load command, we determine the load characteristics in the lower left corner. In this section, we see that GE has been given as the tag number by Protostructure. As for the direction of gravity is also taken into account. If you remember, GE load case is defined as user-defined vertical load when creating load combinations. Therefore, due to the vertical load, the Protostructure considers gravity in this section. Then, let's enter the magnitude value we need to define for the load as 0.100, and then let's load the GE on all panels with the dragging method. As another load case, let's choose the S load case for snow loading. After choosing the area load again, the label has changed and the direction of gravity is taken into account again. Let's enter the magnitude as 0.075 and then add the loads again by dragging method. Now let's choose the WX load case for the wind load definition. In this load case, we should pay attention to the fact that the wind loads act vertically on the panels. So here we have to consider local coordinate systems. Let's show the local axes of the cladding panels with the Open Local Coordinate System option in the side menu. As stated on the icon, red indicates 1, green 2 and blue 3 directions. The wind loads to be applied on these panels should be applied in the blue direction, which is in the local 3 direction. After selecting the WX load case, let's choose the area load command, and we see that you have been assigned a label as WX in the load properties section. In terms of direction, local 3 selection was made. Local 3 selection is determined automatically by ProtoStructure. Let's load 0.0962 as a magnitude value, then we can load all the panels by dragging method. In order to change the direction of the loads applied on the panels, when we click once on the panel, the load properties will open, or we can choose edit from the right-click menu. In this section, if we want the load to be applied from top to bottom rather than bottom to top, it is sufficient to put a negative sign in front of the magnitude value and select the update option. Thus, the direction of the load is changed. To undo the change, the forward and reverse button in the upper left corner can be used. At the same time, we can use the Ctrl-Z and Ctrl-Y shortcuts here. We can use the Delete Loads command to delete the added loads. In this section, we see the loads that we want to delete in bulk. For example, when we want to delete only GE loads and we want to delete area loads, we can make these selections and delete these loads that we have added with OK. Let's choose the Report command to report the loads we have added to this cladding group that we have chosen between 2 and 5 axes. From this section, we can select which load cases we want to generate reports for, or all of them can be selected. Then, we can create reports based on load type or load case. In the generated report, the label of the cladding defines the label of the load on the cladding, panel names, the name of the load type as the area load, the name of the load case, the direction of the load, and the information about the magnitude of the load in these reports. The generated reports are saved to the project file location in PDF or Word format. Now let's close this window and examine how to load other panels. In order to quickly view the loads we have added on the claddings, it is enough to move the cursor over the relevant cladding so that we can quickly see the loads defined on the cladding in the drop-down label. We can define cladding groups separately, as well as view and assign loads on a floor-by-floor basis. For this process, we open the Load Editor command in the Load tab. If you pay attention here, Floor 1 denotes active floor. When we run the command, an interface with the active floor opens. Since we define the hangar structure as 1 story, we are now viewing all the claddings in the model. In this interface, we can view not only the cladding elements, but also all other structural elements. In the Load Types menu, in addition to the area load, there are options such as point load, distributed load and trapezoidal load. In the View option menu, we can change the appearance properties of this interface. For example, we can enable cladding objects to be displayed in solid mode or as transparent from the settings in this section, or we can display it by combining the loads on the elements. The loads that we define as the GE load, that is, the solar energy system, that we are displaying in this section, are specified as the area load on the claddings. At the same time, we display the distributed loads as line loads on the purlins to which the coating is attached. We can use these loads for control purposes. We can remove these loads from the view using the Close Distributed Loads option. Let's define all the cladding weights in our project by switching to the G-load case. If attention is paid to this section, all structural elements are displayed. When we only want to load claddings, we can load the skins more easily and quickly by filtering them. For this process, let's turn off the visibility settings of the objects in the last side menu individually or collectively, and then turn on the appearance of only the claddings. Let's get a top view by using the view cube to define cladding only to facade elements on the roof. Then, let's select the cladding objects on the roof and right-click to apply the filter option. Thus, only the cladding objects on the roof will be displayed. Then we can load with the Area Load command in the Load Types menu. Or we can copy and paste existing cladding weights onto other blank panels. Let's right-click on the cladding load between the 4 and 5 axes and select Copy, then select the panels between the 5 and 6 axes and tick the Paste option. Similarly, let's define the cladding loads between the axes 1 and 2. To view the facades again, right-click and tick Clear Filters. Then, let's get the right side view, select all facade panels and mark Filter from the right-click menu. Thus, the facade panels are selected as a group. Let's select the Area Load command and assign the 0.035 load for the area load by selecting all facade cladding. Thus we collectively defined the cladding weights of all facade objects. We can view it again with all facade panels with the Clear Filters option from the right-click menu. In order to generate the reports of the cladding loads we have added, let's go to the Report menu in the top menu. In this section, listing can be made on the basis of floor or element type. After selecting the element types, we select the cladding object and select the claddings assigned for the first floor and add them to the selected elements group on the right. Then let's select all the cladding objects and select the continuation. In this section, we can see that the load cases are marked. Let's deselect the load cases we want to add to the report. In the Load Types section, let's choose the Area Load again. In this section, two different reports can be presented depending on the load type or load case. When we select the Create Report option, the Element Loads report is opened. In this section, depending on the label of the cladding, the labels of the loads assigned to the cladding are defined, the panel names, the load types, the load state, the direction in which the load is applied, and the size of the load options are presented in a table. The generated reports are saved to the file location of the project in PDF or Word format. Let's choose the PDF format. This report you created is saved in the Reports folder in the project's file location, so that we can add these reports to the main report later from the Report Manager. Let's close the window. Notice that after defining the loadings on the claddings, we have created the load reports on a cladding basis or a story basis. We can create load reports for each cladding object or for each floor separately, as well as from the Reports section in the Drawing and Reports menu. In this section, the load reports for the floors to be defined collectively can be created and saved in the report folder in the project file location. Thank you for watching. We examined the load definition and load reports on the claddings within the scope of this video. See you in the next video.